nearly 6.5 tons. And with 260,000 litres of fuel loaded inside 10 interior locations, the wings are also flying fuel tanks. They're one of the most critical structural components in the entire aircraft. The precision construction process begins with sheets of aluminium. Destined to be shaped into the 10 panels that cover each wing, each piece has its own shape and weight requirements. To whip one up, just follow 3 not-so-easy steps. Shade it, wrap it, then bake it. This 34-metre-long slab of aluminium weighs in at 5 tons. Way too heavy for the wing panel it's destined to become. In its final form, it will weigh close to 1 ton. So off it goes, to get the aerospace version of a tummy tuck. Overhead cranes use 32 powerful suction nozzles to lift and transport each aluminium slab. Tim Fernifer carries the burden of responsibility. Using a remote-controlled steering device, Tim guides the 5-ton piece of metal across the factory floor. But he can't do it alone. His team must watch the motion of the wing panel throughout the ride.
You've got to be particularly careful that I'm handling it. But I can't see down the other end, so I need another pair of eyes down the other end. It's just health and safety issues. We have to watch, make sure everybody's out of the way when it's actually moving.
It's a dicey ride across the factory floor before the huge sheet can settle safely into position. Now under the control of a massive horizontal metal shaping device, a milling machine 40 meters long. Like an oversized cheese grater, the precision cutting head slowly cuts back and forth across the surface of the wing, painstakingly shaving the aluminium until the panel shape matches the 3D contour map stored in the machine's computer. The process takes up to 3 days. It eliminates 75% of the panel's weight while maintaining its strength. Then it's ready for the oven, one of the world's largest pressurized heat chambers, 42 meters long, almost 6 meters wide. Technician John Massey has cooked plenty of wings for smaller Airbus planes, like the A380.
It's a challenge to see it go from the size of the 320 to the size of the 380. It's a huge, huge jump.
The A380 wings are 50% larger than A320 wings. That means a 50% greater chance of error in this critical process. Baking requires careful setup. First, Massey and others place the segment in a special metallic form. Then they vacuum seal the entire assembly with a massive piece of plastic shrink wrap to protect the metal from contamination. Inside, the heat must be uniform across the entire panel, 150 degrees centigrade, with no room for error.
We try to avoid any changes in the vacuum or the temperature, so the temperature must remain constant right throughout the process. It must maintain within 3 degrees, otherwise the run is invalidated.
After 24 hours, the panel is ready. Specially equipped vehicles rise up and move into place in front of the oven. All eyes are on the plastic protecting the wing panel. If it breaks, the aluminium wing piece is compromised. A disaster. The entire wing panel would be worthless.
If the bag bursts, it means starting the job again from scratch.
Anxiously, they scan the surface for any breach. At last, the wing is cool enough to touch. And good news, the bag appears to be intact. Finally, the wing segment arrives in its docking bay. Here, the technicians first remove the plastic and cloth wrap. Now begins the tedious search for flaws. John's boss, Garrett Williams, arrives to inspect the piece. He retrieves small metal rods that were baked onto the top of the wing panel. Each of these cylinders tells an important story about future safety.
These are test pieces which are made of the same material as the wing panel, and we use them to confirm that the heat process that this part's just gone through is correct and it's to the right specification.
When this testing phase is complete, Gareth and John get the okay to move the wing to its next destination. The nearby wing assembly plant, an enormous brand new factory located just up the road. It's one of Britain's largest industrial buildings built in this century. It's nearly 85,000 square meters in area, equal to 12 full-size football pitches. This is where the builders attach the aluminium skin panels to the wing skeleton. George Lee guides his team through the tricky assembly process. Today they're preparing to lift and place one of the largest of the 20 aluminium panels, 34 meters long and weighing in at more than 1 ton.
Size is a great challenge because everything requires some form of overhead lifting. Nothing can be lifted manually, so virtually everything requires overhead craneage movement, and therefore the management of the craneage system is very, very important.
The panel hangs like a huge guillotine, suspended over the factory floor. But that's not all that's hanging over the assembly team's head. Time is running out. Along the edges of the partially constructed wing, builders have applied a sealant that'll help to ensure the integrity of the fuel tanks. The sealant dries quickly within hours. The team must fit the wing panel into place before the sealant dries, or the wing could be defective. This time they're cutting it close.
The only concern I've got is the time factor.
If they don't succeed, the team will have to scour the sealant off the aluminium surface and start the whole process again. Finally, the panel settles into place. 1 down, 9 to go.
It can be stressful, yeah, it can be stressful. At this certain times, it's an enjoyable job, because when it actually all works and goes together, it's quite enjoyable. You've made it an achievement.
Now it's time to glue and bolt together the pieces, like building the world's biggest model airplane wing. This part of the process remains a carefully guarded trade secret. The company wants our cameras off.
No cameras.
The secret assembly process inside the jig will take nearly 4 weeks to complete, but it takes more than a wing to make a plane.